Hello, I'm min-jeong, the second semester of the master's course in Artificial Intelligence at Korea University. I'm gonna start my presentation. The project title is Real and Fake Face Image Classification using Deep Learning. My project objective is improving the performance of deep learning models to classify fake face images and real face images so that fake images are not used for malicious purposes. The motivation of the project is ensuring information integrity. About this, there are three motivations of my project. First is the deep learning technology has been mostly used in the legitimate applications such as for entertainment and education, etc. But the malicious users have also exploited them for unlawful or nefarious purposes. For example, high quality and realistic fake images and videos have been created to spread misinformation and propaganda, foment political discord and hate, or even harass and blackmail people. Second, fake face images often generated through technology like deepfakes can be used to spread misinformation and false narratives. If these fake images are mistaken for real ones in news outlets or on social media, it can lead to public confusion and undermine trust. Last, for these reasons, it is necessary to advance technologies that can accurately distinguish between the real face images and fake face images. Next slide is about dataset. This data source is Kaggle dataset, and the dataset consists of two categories, real face image and fake face images generated by using GAN model, and it is structured to enable classification tasks. The dataset includes the total of 1,709 images, where 949 are real face images and 760 are fake face images. So speaking of data splitting strategies, to facilitate effective model training and evaluation, the dataset have been divided into three subsets: training, validation, and test dataset. First is training dataset. This subset contains about 60% of the total dataset. It includes both the input images and their corresponding label, real or fake. And validation dataset. The validation set comprises about 25% of the total dataset. Like the training set, it includes both input images and their labels, real or fake. The test dataset includes about 50% of the total dataset. This set contains only the input images without any label, like ground truth. So the participants will use this dataset to generate predictions, and this predicted output will be submitted to evaluations. Now I will explain the baseline model. The classification model used in this project is based on the pre-trained ResNet 18. It is a model that solves the problem that learning becomes difficult as the network deepens in the deep learning, in general by introducing residual learning. Key connection, that is the residual learning. It is a structure in which the input of the layer is added to the output of the layer, helping the network learn only the residue, thereby preventing performance degradation even in many learning. ResNet have several variants with varying depths, the most common models being ResNet 18 and ResNet 34, 15, 101, where the number represents the number of layers in the networks. ResNet shows very high accuracy in image classification tasks such as the ImageNet and Cypher10, and is adopted as the basic architecture for many models. It also has the advantage of being easily utilized in various networks due to its modular structures, and I choose ResNet 18, a lightweight model with only 18 layers, to benefit from this and resource-limited environments. And the optimizer used is Adam with the following training parameters: batch size of 32 and 10 epochs, and a learning rate of 0.001. Transforms of the dataset for training and validation are a random horizontal flip to the training data and resized or image to 224 by 224 and normalized them. The model performance of training and evaluation. After training the model, the training accuracy was 88% and the training loss was 0.317. The validation accuracy was 65%, which shows a drop in performance compared to the training set. Visualizing the loss and accuracy over each epoch, we can observe that the model's performance improved gradually during training. This is it for the presentation of the project proposal I prepared. If you have any question, please contact me by mail at the bottom. Thank you for listening my presentation.